Hi everyone, and welcome back to the tutorials. If you remember, in the package of CiliaQ, we have 3 different plugins. And today we are going to talk about CiliaQ Preparator. So as mentioned before, CiliaQ Preparator pre-processes the image for segmentation and segments the image into cilia and background. The processing steps in CiliaQ Preparator are particularly helpful for analyzing images in which cilia and background do not show overall distinct intensity levels. For example, when we have ciliary labeling, which is varying between and within cilia, or when larger background structures are also labeled by the ciliary marker. So your image of interest can be TIFF files or a raw microscopy file. And CiliaQ Preparator opens these raw microscopy files by using the plugin named Bioformat, which is pre-installed in Fiji. It is important to make sure that your image is saved on the hard disk because CiliaQ Preparator saves the output data to the path where the processed image is stored. So only saved images can provide that path for Fiji. And if you subject an unsaved image to CiliaQ Preparator, you will receive an error message and processing will fail. Now let's get to Fiji and let's start from the beginning. For launching CiliaQ Preparator, you need to go to Plugins, CiliaQ, and click on CiliaQ Preparator. You will see a dialog like this pop up on your screen. And it has multiple options inside. And we can go through them together and check what these options are and what they will do for us. So if you check the process option here, you can see that there are 3 different options that you can choose between. First, we have active image in Fiji. And this option will provide you the opportunity to process only the currently opened frontmost image in Fiji. Then we have multiple images, and here you can generate a list of images that you want to process. And then we have all images open in Fiji, which here all the images that are open in Fiji will be processed one and after the other. Generally, when subjecting multiple images to CiliaQ Preparator, the plugin will process the images one after the other. And this batch processing is particularly helpful for large data sets as it allows you to run, for example, 100 images just by one click, and then as no further user interaction is required, you can spend the time on something else while the images are processed. So the second option that we have here is preferences. And you can see that we have 2 different options inside this as well. And first we have manually enter preferences, which if you select this option, you can enter preferences manually in a second dialog that will pop up later if you confirm this dialog. And then we have load preferences from existing CiliaQ Preparator metadata file. And by selecting this option, you can select the CiliaQ Preparator metadata file later. And I will tell you later how you can generate this metadata file and why it's useful and how you can use it. But it's basically easy. It's just loading the metadata file that you will generate later. Also, here we have another option, which is output image name. And here you can specify whether you want the output image name to contain the date or not. But it's good to know that CiliaQ Preparator automatically overrides while saving. And this means if you process an already analyzed image again, the output file from the previous analysis will be overwritten. If you check the option to include the date and time in the output file, previous analysis will not be overwritten because the output files differ in terms of the name, and you have to be careful when analyzing your images if you want to analyze an image maybe with different options more than once. Last, we have output number format, and we have this option here, and here you can select number format of US with a dot, or Germany with a comma. And this is important to check how your Excel shows the digits, because for further analysis after CiliaQ plugin, you will need this. So we have also this other option that you can check it, which basically keeps your computer awake until the processing is done. And it might be very useful for you if you have multiple images that needs to be processed. And by clicking on this, your computer will stay awake and your analysis will not be interrupted. So by confirming this, by clicking on OK, you will go to the second dialog. I came to this dialog because I chose the manually enter preferences option so that I can manually put the settings that I want to apply for my images. Because it's good to just check for different images in different data sets, the different types of settings, and see which one works best for your data set. So in this first dialog, you can set the parameters for the main channel that you want to segment to a separate cilia object from the background. And it's this one, channel number. And here you basically put the number of the channel that you have recorded your ciliary marker in. Now, usually the default settings work the best in this whole dialog, but as I said, according to your data, you may need to try out different settings. This first option here, include also an unsegmented copy of the channel, will help you have an unsegmented copy of your channel that you have recorded your ciliary marker in, and it basically duplicates that channel before it segments it. Next, we have subtract background before segmentation, and this option subtracts the local background. So it basically improves the contrast between background and cilia. And when a very small value is set here as the radius, you can also use this function to subtract objects larger than cilia from the image, and thereby you can improve segmentation when the ciliary labeling method also labels other structures which are larger than cilia, or when you see a high background fluorescence in the images. Next, we have divide background before segmentation, and this option divides the image by a blurred copy of the image and normalizes to local intensity levels. And it is useful when there is large variation in intensity levels across the image and even within cilia. Let me explain this with an example. Here I have images from zebrafish embryo spinal cord, and in these images, you can see very high background in the ciliary channel. The ciliary marker, especially acetylated tubulin, which you can see with magenta in these images, also stains neurons. And so analysis in these kind of situation is very challenging. But with using the background processing tools from CiliaQ, we can retrieve cilia. So when we select this option, divide by background, CiliaQ Preparator will make a copy of the image and it will blur it with a Gaussian blur. And then the original image is divided by the blurred one, and the resulting image, which you can see here, is intermediately stored in the 32-bit format for determining the threshold and deciding which pixels are considered foreground and which ones are background. This option is very useful because it levels the intensity level in cilia, and basically all cilia will have the same level of intensity after using this option. It also removes the larger background noises like these that you can see here, and we can segment the cilium very well from the background using this option. Next, we have smooth with Gaussian blur, and this option smooth the image. This option is very helpful when the signal to noise ratio of the image is very low. And let's go and take a look at an example for this one as well. So in such cases, when you have a very low signal to noise ratio, this option will better connect cilia to more smooth objects and reduce incorrect identification of background and cilia pixels. Back to the dialog, we have also segmentation method, but I will come back to this one because it's a longer story. If we go further though, we can see stack handling here. And you can select one of the three options that are provided here. We have apply threshold determined in the stack histogram. We have apply threshold determined in a maximum intensity projection, and we have input image is not stack. And for detection of cilia, apply threshold determined in a maximum intensity projection is recommended, because relationship of background and foreground voxels is more equal than in a whole stack histogram. You should also check this option threshold every time step intensity if bleaching is observed or if the intensity in the channel changes over time. Then we have segment more channels, and you will select this option and change this option basically if more than one channel should be segmented. Usually it is not required, and it might be helpful when, for example, you have applied two cilia labels and you want to reconstruct from both cilia labels the cilia in the image separately. So you might alternatively use this option as well. Last, we have general settings, and in segmentation styles, you can see two different options. And for CiliaQ, the segmentation style keep intensities above the threshold background removed image is recommended because it allows to retrieve intensities for further analysis and easier editing of the mask in CiliaQ editor. Okay, now if we go back to segmentation methods, you can see that there are multiple options here, and you can select one of the ImageJ's common intensity threshold algorithms like hysteresis threshold or the method Canny3D, but you need to try again what is best for your data set. If you choose an ImageJ's threshold algorithm, this option allows the separation of cilia from background based on the histogram of the entire image. A single intensity threshold is estimated that is applied to assign pixels to foreground or cilia. This option works only very well when there is a high and clear contrast between cilia and background. If not, you should go for either of the two other options. So if here you choose hysteresis threshold and you confirm it, you can see that a second dialog will pop up. And here you have to specify the two thresholds, high and low. And for the segmentation of the image into cilia and background, these high and low thresholds will help you. Basically, high-low thresholds can be determined with ImageJ threshold algorithms or manually. This option is particularly helpful if the intensity level in cilia is largely varying and if the contrast of cilia to background is low. Let me give you another example for this. So basically, this model allows you to use a high threshold to detect cilia, and you should set the high threshold in a way that in any cilium, there is at least one pixel that would be detected. The other pixel of the cilium will then be found based on the low threshold. As the low threshold, you should select a method that will detect all pixels of all cilia, but eventually also falsely detected background structures that are not cilia. In the end, the hysteresis threshold will then combine both thresholds, and all pixels above the high threshold are considered cilia. Pixels between high and low threshold will be considered cilia pixels, but only if they connect to pixels above the high threshold. And all pixels below the low threshold will be neglected. Here in this image, you can see from left to right, first the original image, and then here we have the channel with cilia labeling. And this channel is for the segmentation. And then we have segmentation with the low threshold, and then segmentation with the high threshold, and segmentation with hysteresis threshold using low and high threshold, which is the resulting image. And as you can see, the background and cilia are segmented perfectly. So if I close this dialog and open CiliaQ Preparator again to go back to segmentation methods, and if I choose Canny 3D this time and confirm this by clicking OK, this dialog will pop up. This method performs an edge detection algorithm, and it is combined to a hysteresis threshold and a hole filling algorithm. Threshold parameters can be specified here. For this method, the image needs to be blurred with a Gaussian blur as indicated in the dialog to smooth the edge before performing edge detection. It is connected to a hysteresis threshold method. The alpha determines the sensitivity of edge detection, and you may fine-tune it if non-ciliary background structures are detected or if cilia are not detected at all. So we optimize the settings here in a way for general cilia detection in images, and usually default parameters work very well. All right, now that we went through the options and we have a little bit of background on what we are dealing with, let's take an image and process it together. So if I go to Plugin, CiliaQ Preparator, then I prefer to use multiple image option always. And also I prefer to keep computer awake during processing because sometimes the processing might take longer and I might get distracted and I don't want my analysis to be interrupted. So I will confirm this, and I will also choose manually enter preferences because I want to manually use the options and set the settings. I will confirm this. I have an image that I have recorded my ciliary marker in the first channel, so I will stick to the one. And then I want to use Canny 3D segmentation method. And as I said, For these two options, the ones that are selected already are suggested for CiliaQ analysis. So I confirm this dialog as well. And as I told you, Canny 3D thresholder settings are usually working good for most of the data sets. And let's try and see if they are good for our case as well. So I confirm this as well. And then the last dialog that you will deal with will pop up here. So you have different options and you can see select file individually here. I will go to the folder that I have my image stored in, and I will choose the image. Now, if you have more than one images, you can select all of them and then open. And the only thing that you need to do is clicking on Start Processing. And here you can see that there are different sections. One is for remaining files to process, which you can see that in my case, I have two images here because I have recorded two images in the raw microscopy file that I have fed into this dialog. And so CiliaQ Preparator will go through each of those images and processes them. And then when processing is done for one of the images, instead of it being here, it will move to this section, which you will see later. Here, there's a bar that you can see the progress of your processing. And in the notification section, if there is any errors, you can see what are those and how you can deal with them. Okay, now that the analysis is done, you can see this message here. And since we don't have any errors in this part, we can be sure that our analysis is successfully done and we have our output files. So if we open the folder that our image was stored in, you can see the output files. By clicking on this text file, which is provided for each image, you can see that there are all the settings that we have used, including the channel number that we wanted to segment it, the unsegmented channel that you can see here, the method of thresholding for segmentation that we used. And so this is basically that metadata file that I was talking about at the beginning of this video. And when you want to load the same settings for the data set that you have tested these settings and you are happy with them, you can easily just upload this into the CiliaQ Preparator and use the same settings for the rest of the images that you have. Now, if I open one of these images and compare it with the last image that we had, here we have the output file And here we had the raw file. And you can see how much easier it is and how good the segmentation method worked for this. Okay, now that we know how CiliaQ Preparator works, next time we will talk about how to edit the images that are outputs from the CiliaQ Preparator and how to deal with those edited files. Until then, take care.